In this video, we will focus on simplifying square roots. They're also known as radicals. And the first thing that is very helpful in simplifying square roots is to know the list of perfect squares. If at all possible, memorizing the list of perfect squares will be very, very helpful in this topic. So perfect squares consist of a list of whole numbers that, when squared, give you another number. So, for example, 2 squared is 4. So what does that mean? Well, that means that the square root of 4 is 2. Now, I do want to note something. Technically, -2 squared is also 4. So the square root of 4 should be plus or minus 2. However, for this topic, we will focus just on the positive root. The plus or minus, this is used in equation solving. But for simplifying square roots, we are just taking the positive value of the radical. So let's go ahead and continue the list of perfect squares here. So 3 squared was 9, 4 squared, 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Of course, it keeps going, but we're going to stop right here. So just from this, let's go ahead and do a couple of examples of what we are talking about here. So let's keep this on the screen and switch to an example. Simplify. So if you are asked to simplify a perfect square, it's super easy. Square root of 25. Well, since 5 squared is 25, the square root of 25 is just 5. Same thing if I ask you for the square root of 81. 81 is 9 squared, so the square root of 81 is just 9. But most of the time, we are not dealing with something so simple that it is a perfect square. A lot of the times, we have something that is not a perfect square. So, for example, the square root of 12. There's two approaches to deal with square roots that are not perfect squares. The first approach is to break up this 12 into two factors. One of those factors would be a perfect square, and one of those factors would just be a number. So, by the way, factors are just two numbers multiplied together, or three numbers multiplied together, or really any number of numbers multiplied together. So for us, 12 is 4 times 3. So notice that the first factor, the first number, is a perfect square. I know that 12 is also 6 times 2, but neither 6 nor 2 are a perfect square, so that's not going to work here. So now that we have broken it down, we can represent this as two different square roots, square root of 4 and square root of 3. Square root of 4 is 2. 4 is a perfect square, so square root of 4 is 2. Square root of 3 just gets rewritten. So this is one approach. Another approach, the exact same problem, but a different approach, square root of 12 equals. The other approach uses your ability to break any number into prime numbers and then go from there. So you take the number from underneath the radical, you break it up into primes. So 12 would be 4 times 3, and then 4 is further broken down into 2 times 2. So that means that 12 as a product of primes would be 2 times 2 times 3. Now, any number that repeats itself twice, so these two numbers, you are going to just take one of those and you're going to put it on the outside of the radical. So here's this 2. The number that does not repeat itself, which for us is 3, it stays under the radical. The radical being that symbol right there. So we're going to rewrite that as square root of 3. So either approach is valid. They obviously give us the exact same number, so just use the one that is closest to you. So I'm going to go ahead and clear the screen, and we're going to try this with a few examples. Let's go ahead and do examples, and we're going to simplify. So let's start with the square root of 24, and I'm going to do both approaches. The one where we're just looking for factors that are a perfect square, and one where we're breaking it up into prime factors. So for 24, the perfect square would be 4. 4 times 6. Then it is the square root of 4 times the square root of 6. Square root of 4 is 2. Square root of 6 just gets rewritten. So this is the final answer. And now on the right, I'm going to do the same exact thing, but with a prime factorization. So we have 24, we're going to break it up into primes. 24 would be, well, let's just use 4 and 6. A 4 will be further broken down into 2 times 2, and 6 will be broken down into 2 times 3. So 24 can be written as 2 times 2 times 2 times 3. Now you have to group them. So the ones that repeat twice, just twice, you're going to take one and you're going to put it outside of the radical. So just one. Then you're going to open up the radical back up, and everything that's not paired up, so for us it is 2 and 3, neither one of them is paired up with anything else. Both of them are going to go inside that radical, which will give you 2 square roots of 6, which is what we know the answer already is. So let's try this one more time. Square root of 45. 45 is 9 times 5. So it's the same as the square root of 9 times the square root of 5. Square root of 9 is 3. Square root of 5 gets rewritten. So that is the method where you're just breaking it up into something that is a perfect square. And then the other methods, so we have square root of 45 equals 45 needs to be broken up into prime factors. 45, let's just start with 9 and 5. 5 is already a prime. 9 will be broken up into 3 times 3. So 45 is the same as 3 times 3 times 5. And once again, you're going to pick the ones that are paired up. You're going to just take one, put it outside of the radical, then open the radical up, and the leftover number, the one that's not paired with anything, that goes inside the radical. So it's still 3 square roots of 5, which of course has to be the exact same answer as what we got on the left.